If you've been experimenting with kitchen scraps in your garden, or, following the latest regenerative gardening trends, you've probably heard whispers about using rice as a soil amendment. Some gardeners swear by adding cooked rice to their compost, or directly incorporating it into beds, claiming it feeds beneficial microbes and improves soil structure. But here's the question almost nobody is asking: does the type of rice actually matter? Most gardeners assume rice is rice, treating white and brown varieties as interchangeable when it comes to soil health. After conducting extensive side-by-side trials in our garden lab, we've discovered that this assumption couldn't be further from the truth. The difference between white and brown rice in garden soil are not subtle. They're dramatic, measurable, and have significant implications for your plant's health and your soil's long-term vitality. Before we dive into the soil showdown results, understanding the structural and nutritional differences between white and brown rice is essential because these differences directly translate to their behavior in garden ecosystems. Brown rice is the whole grain with only the inedible outer hull removed, leaving the nutrient-rich bran layer and germ intact. This bran layer contains oils, B vitamins, minerals like magnesium and phosphorus, fiber and protein. White rice, conversely, has been milled to remove both the bran and germ, leaving only the starchy endosperm. This processing extends shelf life and creates a softer texture for eating, but it strips away approximately 67% of the vitamin B3, 80% of the vitamin B1, 90% of the vitamin B6, half of the manganese and phosphorus, 60% of the iron, and all of the dietary fiber and essential fatty acids. From a soil perspective, these nutritional differences become feeding opportunities for different microbial populations. Brown rice, with its complex structure of bran, oils, proteins, and fibers, provides a diverse buffet that supports a wide range of decomposer organisms. The oils and proteins are particularly valuable because they feed bacterial populations that form the base of the soil food web, while the fibrous bran supports fungal decomposition. White rice, being primarily simple starches, offers quick energy to bacteria but lacks the structural complexity and nutritional diversity that builds robust soil ecosystems. Think of it this way: white rice is like feeding your soil microbes candy, quick energy, but little long-term nutritional value. Brown rice is like offering them a complete meal with proteins, fats, and complex carbohydrates that sustain diverse, healthy populations. We established 3 identical raised beds filled with the same base soil, a standard garden mix with moderate fertility and decent structure, but nothing exceptional. Each bed received identical watering, sun exposure, and environmental conditions. The first bed received 2 cups of cooked brown rice, thoroughly mixed into the top 6 inches of soil. The second bed received 2 cups of cooked white rice incorporated in exactly the same manner. The third bed served as our control, receiving no rice amendment whatsoever. Into each bed, we transplanted identical seedlings of lettuce and radishes, chosen because they're quick-growing indicators that respond rapidly to soil conditions. Within the first week, visible differences began emerging. The brown rice bed showed signs of active decomposition, with the rice grains developing fuzzy white coatings of beneficial fungi and bacteria. The soil around these decomposing grains felt slightly looser and more friable when examined. The white rice bed showed decomposition as well, but the microbial colonization appeared less robust and more uniformly bacterial, without the diverse fungal networks visible in the brown rice bed. The control bed remained unchanged, as expected. By week 2, the lettuce in the brown rice bed displayed noticeably darker green leaves and more vigorous growth compared to both the white rice and control beds, which showed minimal difference from each other. The most dramatic differences appeared between weeks 3 and 5. The brown rice in the soil had almost completely decomposed, leaving behind a network of fungal hyphae, which you could see as these white threads running throughout the soil structure. When we carefully excavated sample radishes for root examination, the plants in the brown rice bed showed root systems that were, 30 to 40% more extensive than the control, with numerous fine root hairs and visible mycorrhizal associations coating the roots. The white rice bed plants showed marginal improvement over the control, maybe around 10 to 15% better root development, but, honestly, nothing approaching the brown rice results. The white rice grains themselves decomposed more slowly and left the soil feeling just a bit slicker rather than more friable, which suggests different decomposition byproducts at play. By week 8, the final harvest told the complete story. Lettuce heads from the brown rice bed averaged 42% larger than control bed lettuce and 31% larger than white rice bed lettuce. The radishes showed even more dramatic differences, with brown rice bed roots averaging 58% larger than control radishes and 43% larger than white rice radishes. Beyond just size, the quality differences were honestly pretty striking. Vegetables grown in the brown rice bed showed this deep coloration, crisp texture, and a really robust structure, all of which are associated with optimal nutrition. Meanwhile, vegetables from the control and white rice beds looked, well, adequate but kind of unremarkable. When we went ahead and analyzed the remaining soil, the brown rice bed showed measurably improved structure, with better aggregation, increased organic matter content, and, get this, noticeably higher earthworm populations compared to the other beds. So, the superior performance of brown rice in garden soil really comes down to how it feeds and supports soil biology. The bran layer on brown rice has oils and proteins that are especially valuable to bacterial decomposers. As these bacteria multiply to consume the rice, they themselves become food for protozoa and beneficial nematodes, which then release plant-available nitrogen through their waste products. This nitrogen cycling provides a slow-release fertility boost that persists for weeks. The complex carbohydrates and fibers in the bran support fungal decomposition, and these fungi form extensive hyphal networks that physically improve soil structure by binding soil particles into stable aggregates. These aggregates create the pore spaces that allow both air and water to move through soil efficiently. Perhaps most importantly, the diverse nutrient package in brown rice encourages a diverse microbial community. Soil health research consistently shows that microbial diversity correlates directly with plant health and disease resistance. A soil dominated by just a few bacterial species processing simple starches, as we saw with white rice, may show some improvement over bare soil, but it doesn't build the complex food web that characterizes truly healthy garden soil. The brown rice beds developed this complexity, and it showed in every measurable parameter from plant growth to soil structure to pest resistance. Interestingly, we noticed significantly fewer aphids on the brown rice bed lettuce, likely because the plant's improved nutrition made them less attractive to pests, and because the diverse soil ecosystem supported more predatory insects. The decomposition rate differences also matter practically for gardeners. White rice's slower breakdown meant it tied up nitrogen longer as microbes worked to decompose it, potentially creating a temporary nitrogen deficiency. This explains why white rice bed plants initially showed little advantage over the control. They were actually competing with microbes for available nitrogen. Brown rice decomposed faster because its protein and nutrient content meant microbes didn't need to scavenge as much nitrogen from surrounding soil to support their populations. This faster decomposition also means brown rice begins improving soil structure and releasing nutrients sooner, providing benefits within the same growing season, rather than requiring months to show results. Based on these results, brown rice clearly deserves a place in your soil building toolkit, but application method matters tremendously. The most effective approach is incorporating cooked brown rice into soil 2 to 3 weeks before planting. This gives the initial decomposition phase time to occur without creating competition for nitrogen during the critical seedling establishment period. Use approximately 1 to 2 cups of cooked brown rice per square foot of bed space, mixed thoroughly into the top 4 to 6 inches of soil. The cooking process is important because it breaks down the rice's structure enough to accelerate microbial colonization, while the moisture from cooking provides the hydration decomposers need to begin their work immediately. For established beds during the growing season, you can use brown rice as a top-dress amendment by spreading cooked rice around plants and covering it lightly with compost or mulch. This prevents any odor issues from surface decomposition while still delivering the microbial benefits as the rice breaks down. This technique works particularly well for heavy feeders like tomatoes, squash, and brassicas midway through the growing season when they need a fertility boost. The decomposing rice creates a localized zone of enhanced microbial activity that benefits nearby root systems. You can also add brown rice to compost piles, where it functions as both a moisture source and a nitrogen-rich green material that balances carbon-heavy browns like leaves and cardboard. An often overlooked application is using brown rice water, the starchy liquid left after rinsing rice before cooking, as a soil drench or foliar spray. This water contains dissolved starches, trace nutrients, and compounds that feed beneficial bacteria. Dilute rice water 1:1 with regular water, and apply it to soil around plants, or spray it on leaves in early morning. The bacterial populations that multiply to consume these simple sugars produce biofilms that protect leaf surfaces from pathogenic fungi and help soil particles aggregate around root zones. This technique offers benefits without the nitrogen tie-up that can occur with solid rice additions and works beautifully for container plants where incorporating solid amendments is less practical. White rice's poor showing in our trials doesn't mean it has no place in gardening, but its applications are more limited and specific. The simple starches in white rice do provide quick energy for bacterial populations, which can be useful when you need rapid microbial activity for a specific purpose. For example, when starting a new compost pile, adding small amounts of cooked white rice can jumpstart bacterial populations that generate the heat needed for hot composting. The quick energy carbohydrates give bacteria the fuel they need to multiply rapidly and begin processing other materials in the pile. White rice can also serve as a moisture-holding amendment in extremely sandy soils where water retention is a critical challenge. As white rice decomposes, it forms a gel-like substance that temporarily holds moisture in the root zone. However, this benefit is short-lived compared to long-term solutions like adding compost or biochar, and it comes with the nitrogen tie-up issue we observed in our trials. For most gardeners in most situations, brown rice simply offers better value because it provides the same potential benefits as white rice, plus all the additional advantages of its nutrient-rich bran layer and its ability to support diverse microbial populations. The cost difference between white and brown rice is minimal when you consider that you're using small quantities as a soil amendment, rather than cooking large batches for eating. A 5-pound bag of brown rice will amend a significant amount of garden space, and the improved results easily justify any price premium. If you regularly cook brown rice for your household, saving leftovers specifically for your garden creates a zero-waste system where food that might otherwise be discarded becomes a valuable soil input. This aligns perfectly with regenerative gardening principles of closing loops and minimizing external inputs. The evidence from our 8-week trial overwhelmingly crowns brown rice as the champion for garden soil health. Its complete nutritional profile, diverse microbial support, superior soil structure improvements, and measurable plant performance benefits make it the clear choice when you're deciding which rice deserves a spot in your garden beds. We encourage you to run your own version of this experiment, adapting it to your specific soil conditions, climate, and crop choices. Document what you observe, pay attention to the subtle differences in plant vigor and soil feel, and, share your findings with the gardening community. Every garden is unique, and your results will add to our collective understanding of how kitchen scraps can become powerful soil amendments. Subscribe to the Living Soil Lab for more head-to-head comparisons, soil-building experiments, and regenerative techniques that, honestly, transform how you grow food. Share this video with gardeners who love testing new methods and optimizing their soil health through observation and experimentation. Together, we're building a community that looks beyond conventional wisdom to discover what actually works in the dirt.